All right, folks. So we are talking about logarithms one more time. Okay. Now, logs are just as they follow here. Sorry, I'm going to edit that out. All right. So, talking about logs. Logs are a way for us to rewrite an exponential function, essentially. Now, the way that you're going to hear me speak with logs for the most part is going to be like this: log base b of a is x. So we have our log, we have a base, we have some number a, and what it equals on the other side. Now, this is going to be a lot to get used to at first, but once we go through and get used to it, it won't seem as intimidating. All right. Now, main questions for us is what exponent is required to go from the base of b to reach the value of a. Now, to get a little further in this, we got to know about what these two forms are for logs so we can go back and forth and answer that question. All right. On the left side of this, we got the exponential form. We've been dealing with that in the past, but now we're actually going to go through and expand on it. So we have some base to an exponent gives us our answer here in purple. The way that the log form is formatted is that we have the log to remind us that we're dealing with some sort of exponential. We have the base as our small number. In front of it, we have the answer to the exponential. And on the other side, we have the actual exponent as our answer. So you are thinking of what base do we take our number, sorry, what power do we take our base to get to this answer? So we're going to go through some experiments on this page so we can get used to how this thing is formatted. Because to be honest, the first couple of times you deal with it, it is a little weird to think of it like this. So we're going to deal with a couple of these on the left side, a couple of these on the right side, and you will hopefully be fine by the end of it. So anybody need me to go up on the page so they can see anything that they might have missed? Now we're cool. All right. We're going to be going on the inside of this. So I'm going to show you the first two already worked out, and then we're going to talk about the next couple, okay? So we can get used to the math involved on it. All right, let's drag this over. All right, so we're going to calculate the following logarithms. So what we're looking for in order to calculate is to find what the exponent is in this case. So we got the log base 4 of 64 equals something. So the way that we deal with this is we're going to change the log into exponential form. Now, everything here is present except for right now, this 3. So essentially, all I'm doing is asking myself, what number can I take 4 to get to 64? And that number would be 3. That's all the answer is that we're looking for. We're looking for what that power is to bring us from point A on the right, sorry, not the right, the left, over to 64 on the right. Same thing happens over on the right side here. We got 6 to the third gives us 216. All I'm asking for is what is the power of 6 that takes us to 216. Now, all that can be done with a little bit of know-how, a little bit of math, but, it just takes some practice at first, okay? So, main thing is we got to know where stuff has to go from this form as a log to the other form as an exponential equation. So, let's talk about our next two here to get used to this form and how it changes. All right, what I've done here is I've drawn out these 3 boxes. In the red, we got our base, okay? In the black, we got our exponent. I'll write that as EX. And then over here in purple, we got our answer. So from our log here, we got log of 4, sorry, log of base 4, 16. So we're asking, what is the base 4 taken to give us 16? So I'll just pop 16 over here. I'll take my 4, pop that over here. So 4 to what power gives us 16? What would that be? 2. So our answer to this log is 2. So it's just kind of like changing this form into something that we've dealt with, kind of like what we did on our little packet just now. All right, so we got another problem here on the right. Let's go through and let's deal with it, okay? So we got some base taken to some power equals some new number. All right, first off, we need our base. So what's our base from this log here? Say that one more time. 3. All right, boom. So we're looking at 3 to some power, and our answer, what's our answer from this log? All right, 1 over 243. All right, two things that we know with our power. When we're going from a whole number to a fraction, we know that there's going to be a negative up here, okay? Next, we're looking for 3 to what power can get you to 243. Do you guys happen to remember that? You said 5? Yep, that would be it. So the answer to this log is -5. So all the answers are for these different logs we'll mess with are the different exponents we would take those bases to get to those answers. You guys want to see any more examples over here on the left? Any other ones down there looking a little suspicious to you? All right, let's hop down there. So 343. This is a case where we have a exponent that's a little different for us. So let me give you the long way. Well, not the long way, the thorough way of dealing with this. All right, log 343. All right, just like with the last one that we dealt with, we are dealing with 343 to some power gives you 7. Now, I know I already got the answer written there, but it's important for you to understand how did I get to that 343 as my possible answer. So I'm going to show you my calculator and show you the steps. All right, here's my calculator. I'm going to calculate this on my side. So I know that I need to go from 343 down to 7. So what I do is I take 343 and divide it by that number in my answer to see how many times it takes for me to get down to 1. This way I can reverse that to figure out what the possible answer is. So I know if I divide 343 by 7, that gets me 49. I know if I divide 49 again by 7, I get 7. And one more time gets me 1. So what this tells me is if I take 7 to the third power, I get up to 343. Now, we're going to keep that 3 in mind. Now, what I have here in the problem is I have 343 as my original base going down to 7. Both of these are whole numbers, which means that I have to take this to some type of root. Now, earlier we messed around with the square root. Let's see if that would work for this. So if you take the square root of 343, you get this jazz over here with 18. That's not exactly what we want to go through and deal with. We knew that we had to take 7 to the third power to go through and get to 343. The reverse of taking that to the third power will be taking the 1/3 power. So if you take 343 to the 1 over 3 power, that gives you 7. Now, the third power is actually another way of writing the third root. If you ever needed to get it, you can just get it from the math menu. And it looks a little bit like this. Instead of nothing being in front of the symbol, you have a little 3 there. And then you would just put 343, like how you do for the square root. Close it up, press enter. Now, if you ever see yourself going from point A to point B, like how we do for this example, and the number's getting smaller, but still staying a whole number, that means that you got some sort of fraction as your exponent. So for this, your fraction is 1/3. Was that a long explanation? Yes, it was. My bad about that, y'all. All right. Y'all got any other ones on here that you want to talk about? See y'all good on the left side of this? All right, cool. Let's talk about the right side real quick before we let y'all loose. All right. Now, this is similar to what we did last week. We did a little bit of practice going back and forth between the log forms. Case in point, just like how we dealt with for our practice on the left, we're going to be changing these to look like logs. So what you do is you take whatever the base is, that becomes your little small number next to the log. Whatever your answer is, that becomes the big number next to the log. And then your power becomes what you are equaling it to. So 1/5 to the x power equals y turns into this. Same thing on the other side. Now, I'm not asking you to solve these because right now we're not at solving them, okay? We're currently at just changing the form back and forth, okay? Well, we did solve a couple of them over on the left, but for these ones on the right, they're two variables. I'm not really trying to make y'all get that deep into it with it, all right? So these are our first two forms. Do y'all want to see two more? Or- You said yeah? All right, let's take a look. All right. We got these two right here. Oop, my fault. My screen bugging out. It's a ghost. My fault. All right, so first off, we got to write our good old friend Mr. Log out. Okay, so we got log. First step we got to do is find our base. Our base is the same base that we have for our problem. So the base is going to be 9. So down here after the G, we're going to write a small 9. All right. Next thing we got is the big part of our log. The big part of our log is what our answer is. So this X comes up right next to the 9, but it's larger, noticeably larger. All right. On the other side now, you put your exponent that you were taking your original base to, that being our Y here. So, bless you. We got log base 9 of X equals Y. That's definitely a mouthful. Sorry about that. All right, same thing over here on the right. Let's go through and just work it out. We got X here. That's our big number. We got 7 over 4. That's our base. And we got Y here from our power. So we're going to turn this back into exponential form. First, we take everything here. We got 7 over 4. You got your power. And you got your answer. And honestly, that's about it. You just got to know where things are going with this and how it's going to go there. Okay? Hmm? Nope. We just got to worry about being able to turn it back and forth. If we don't know how to turn it back and forth between these forms, when we actually have to solve it, it's going to be a lot harder. All right, people. That's about it. Thank you for catching in. See ya. Like, comment, subscribe.